Using the law of sine, we need to show that in a triangle ABC, the following equation is true. So let us begin. First, we will specify the law of sines. For that, we need a triangle ABC. Here, the sides A, B, and C, which is represented by the lowercase letters, these are the sides opposite to angle A, B, and C, respectively. Then, the law of sines states that the ratio of the side A to that of sine of the angle opposite to it, which is angle A, this ratio will be equals to the ratio of side B to that of sine of the angle opposite to it, which is angle B, and it is also equals to the ratio of the third side to that of the sine of the angle opposite to it. So this is the law of sines. Now, in order to solve a problem, what we'll do, we will suppose that let these three ratios be equals to a common constant, and we're going to call it 1 over lambda. Now, what we can do, we can represent sine A as lambda times A. Then sine B will be represented by lambda times B. And sine C will be represented by lambda times C. So we'll begin from the left-hand side of a given expression. So we have A multiplied to sine B. So what's sine B? That's lambda times B. So lambda times B minus sine C, this will be lambda times C. Plus B times, we have sine C, so that's lambda C, minus sine A, so that's lambda times A. Plus C multiplied to lambda times A minus lambda times B. Now what we'll do, we can have lambda as the common factor. We get AB minus AC plus BC minus BA plus CA minus CB. So we can see that all the expressions within the parentheses, all the terms, gets cancelled up. We have AB cancelling out with negative BA, negative AC with positive CA, and positive BC with negative CB. So we have lambda multiplied to 0, which is 0, and this is the expression on the right hand side. Hence, we have successfully showed that the given equation is true, hence proved.